Hello everyone. In the last class, we have completed the first step of designing a learning system, that is choosing training experience. In today's class, we are going to discuss about second step, that is choosing target function. Here the design choice is to determine exactly what type of knowledge will be learned and how this will be used by performance program. Okay, let us begin with the example of checkers playing program. Here we are designing a function or program that will help us to choose the best move out of legal moves to win the game from particular board state. We know that in checkers game, checkers pieces will move only in diagonal forward or backward direction called legal moves. If it is moved in horizontal or vertical means illegal moves. So legal moves means set of possible moves. The term priori is used to represent the set of legal moves. So main aim of choosing target function is to choose the best move among the legal moves. Okay, let us consider the function that chooses best moves as choose move. This uses the notation to this function like choose move b gives m. It indicates that this function accepts an input any board from the set of legal board state B, produces as output some move from the set of legal moves M. We can also represent this function as y is equal to f of x. Here y is the best move, f is the target function choose move, x is the set of legal moves. The problem here is to choose the best move. So even though choose move is an obvious choice for target function, but this function will turn out to be very difficult to learn given the kind of indirect training experience available to our system. In checkers game, we have selected playing game against itself as training experience, which is indirect training example. It is difficult to learn such indirect training experience by choosing target function choose move b gives m. So we can move with the alternative target function, that is evaluation function v, by using notation v b gives r, which denotes that evaluation function v maps any legal board state from the set of b to some real value r, 0, 100, minus 100, etc. And evaluation function v assigns a numerical score to any board state. V with the higher score means better board states. If the system can successfully learn such a target function v, then it can easily use it to select best move from the any current board position. For example, let us define the target value v of b for an arbitrary board state b in set B, such as if b is the final board state, the game is won, then v of b we are going to assign as 100. If b is the final board state, that is lost, then v of b is equal to minus 100. If b is the final board state, the game is drawn, then evaluation function v of b is equal to 0. If b is not a final state in the game, then v of b is equal to v of b dash, where b dash is the best final board state that can be achieved starting from b and playing optimally until the end of game. So with this definition, every board b has a value of either 100, minus 100 or 0. But to compute it, we need to run all possibilities until the final state. So we can call this as non-operational definition because we can't work with it in practice. So the goal of learning in this case is to discover an operational description of evaluation function v, that is select moves within realistic time bounds. In this way, we have reduced the learning task to the problem of discovering operational description of an ideal target function V. But it may be very difficult in general to learn operational form of V perfectly. So in practice, we will try to find an operational definition of an approximation to V. So usually we are going to represent symbol cap to represent the approximation. So we will use the symbol V cap to refer the approximation of ideal target function V. How to determine target function is discussed in this class. Next class we'll move on to the third design choice, that is choosing a representation for the target function. Thank you.